So in last class we discussed about series and parallel combination of cells, and today we will discuss about mixed grouping of cells. So mixed grouping of cells means it is a combination of series and parallel. Okay, so here you can see that a circuit is constructed where in each row like this, just a second. Okay, where in each row means this one, in each row we have n numbers of cells, and all these cells are identical. Identical means their EMF and internal resistance is same. Okay, now in each row we have n cells, but in the same way we have m numbers of rows, means this is first row, second row, third row. In that way the last row is, what is the number of it? It is mth row. Okay, and in each row we have n numbers of cells. Now we can modify this circuit in this way, and how we can do so? Okay, let us see that. Suppose each cell is having how much EMF? E, right? And all are in series in each row. So if they are in series, if you remember, for series we just add up the EMF. So if you add all this EMF like E plus E plus E plus E, in that way how many E will be there? N E's will be there, right? So what will be the total EMF of this row? That will be N E, right? In the same way for the next row also the total EMF will be same, N E. Third row again N E. In that way how many rows? There will be M row. So what we can do is we can construct a circuit like this by removing all these cells by only one cell, which will have a EMF of NE. Okay, that's what is done here in this circuit. Here this is a cell having EMF NE. That means all these n numbers of cells are replaced by this cell. In the same way for the next row also, this is also same. N numbers of cells are replaced by one cell having EMF NE. Okay, in that way how many cells we considered here? M cells, 1 2 3. In that way this is the mth number. Okay, now these cells are in parallel. So for parallel, what is the equivalent EMF? If you remember, in parallel combination, I already told you that the total EMF, if all these cells are identical, so from the circuit it is clear that all these cells are identical, right? So if they are identical, what will be the EMF of this? EMF will be equal to the EMF of one cell. You know this one. In last parallel, while discussing the parallel combination, I gave you this one, E dash or E equivalent. That one was equal to only E. Okay, this E was the EMF of individual cell. So here how much is the EMF of individual cell? So that is NE. So that means the total EMF will also be NE. So that means here we can write here the expression for current. This expression already you got. Current equals to this E dash, means it is equivalent EMF divided by equivalent internal resistance per plus this is the external resistance, this one. Okay, so this E dash will be equal to NE, total EMF, right? So E dash we got. Now what we have to find out is the R dash. R dash means it is the total or equivalent internal resistance. Now let us start with this circuit. So here you can see in each row we have how many cells? N cells, and each cell is having how much internal resistance? Small r. So what is the total internal resistance of this row? R plus R plus R. If that is in series, right? So R plus R plus R. In that way how many are? N numbers of R. So what is the total resistance? NR. For each cell the total resistance, for each row the total resistance is NR. Okay, so that means for the next row also total resistance will be NR. In that way how many NR will be there? M numbers, right? So here you see that when I have replaced all these cells of each row by one cell, I have mentioned that their internal resistance is NR. first NR, second NR, third NR. In that way this will be the mth NR. Okay, so what will be the equivalent now? Now these cells are in parallel, so the internal resistances are also in parallel. So if they are in parallel, suppose their equivalent resistance is R dash, which I have mentioned here, R dash suppose. So if it is R dash, then what it will be? 1 by R dash for parallel, 1 by R dash equal to 1 by NR plus again 1 by NR plus, in that way how many 1 by NR will be there? M numbers. This one NR, 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 in that way M, right? So the next page, this one. Okay. So 1 by R dash equals to this, right? And how many numbers? M numbers. So if it is M numbers, when this will be like, if it is 2, what we will do? If 2 are there, that will be 2 into 1 by NR, isn't it? But now how many we have? We have M, so that will be M into, what is that? 1 by NR. Okay, so that means it will be M by NR. Fine. Now M by NR is the value of 1 by R dash, but we need R dash, so we have to take the reciprocal. So if once you take the reciprocal, it will be NR by M. Alright, so we got the value of R dash, we got the value of E dash. You just substitute this in this equation. This equation means the last one, that is I equal to what? E dash by this equation, this one. Equation 1. So E dash means NE and R dash means the value that we got just now. So if we substitute what we are supposed to get, okay, so we are supposed to get this equation. Alright, now simplifying this, M we can take LCM. Once we do, the final equation becomes like this. Okay, so this is the final equation of the total current flowing in the circuit. Now there is another part, that is condition for maximum current. Now see, this current I can be maximum if this value becomes minimum. Okay, fine. Inversely proportional. So what is the condition for which this value becomes minimum, or in other word, current becomes maximum? So for that what we did is, this value I have written here, this value NR plus MR. Okay, so that should be minimum for the current to become the maximum. Okay, now we are doing some simplification, means NR we can write it root over NR square, no change. MR we can write root over MR square, no change. Okay, then what we did, this one will remain as it is, this one will remain as it is. Just a minute, there it will be square. Okay, fine. Then this term is extra here. So once we have subtracted, okay, just a second. Okay, this term we have added here, and at the same time we have subtracted also, so the value remains same only, there is no problem, there is no change. Okay, and why we did it? So that we can make it a perfect square, like this is a square b square minus 2ab, it gives us a minus b whole square, plus this term will remain here, plus this equals to minimum. So now minimum value means it should be 0 individually, because this plus this is 0, that means what? Individually this also should be 0, this also should be 0, right? But the problem is that this term cannot be 0, because if it has to be 0, out of this 4 term M, N, R and small r and capital R, one thing should be 0, but that is not possible. M means number of column, number of rows, N means number of cell in each row, small r means internal resistance, capital R means external resistance, so nothing can be 0. So that means this term is not going to become 0. So the minimum value will appear only and only if this becomes 0. And if this is 0, what is the condition that we are getting? Square will be removed, this equals to this, or NR equals to MR, or from this R equals to NR by M, right? This is the condition under which the current becomes maximum. And if you see nicely, NR by M is nothing but R dash, this one, right? So that means the external resistance of the circuit should be equal to the total or the equivalent internal resistance, then only the current in the circuit becomes maximum. So this is the condition. Alright, external resistance should be equal to the equivalent internal resistance of the